Hello, everyone. Good morning, good afternoon. Today we have a very sunny day here in Catalonia. Hope you are also having a good weather. And for those of you, as Mohammed, that is your first meeting today, let me first quickly explain what is our typical agenda. So we will first start by going over some metrics about the community, the work that we're doing, and so on. We'll review as well today some of the pretty interesting topics that we are actually preparing for the 1.4 release. We just had to highlight those that fit into one slide, but together with them, we have a bunch of other improvements and fixes. And we'll have two sessions today. The first one is going to be a follow-up on the MetaPilot introduction. We had quickly discussed that on our last meeting, and today we are very happy to move from the Figma that we were showing you the last day to the actual instance where we are going to show you how we are moving Collate into the Gen AI world. And then we have today Pablo here with us, that he has been a huge help into helping us improve the performance of everything related to the Ingestion framework. So that's a bit what it's going to happen today. If you have any questions during the meeting, please feel free to use the chat. We have a bunch of colleagues with us that are going to be there answering any questions as fast as possible. Otherwise, we will also try to put a few minutes at the end for you to raise your hands, raise your voices, and make sure that we can have some nice interactions with you folks that have put the time to meeting us. And that being said, let's just start with the community stats. And I'm actually super happy. We're all super excited because the number of open source developers keeps increasing steadily, meeting after meeting after meeting. So we are already at 238. So thanks to all of us, thanks to anyone that is a new contributor, someone that is contributing back. It's always super exciting for us to see your new PRs, your new ideas, and your ways and suggestions on how we can improve open metadata. So please feel free to keep chipping in. Don't be shy. We also now have this contributor channel in Slack. So any questions that you have, any guidance, we are more than happy to help. In terms of stars, we have a very nice round number today. We are so close to 4,000 stars. I don't want to jinx it, but I see here almost 50 people. So if someone yet has to start the project, this is the right time. Let's see if I remember by the end of the meeting to check the number of stars and see if we actually have been able to cross this 4,000 star OKR here. And yeah, again, this is one of the best ways that you can actually help us spread the word, make the project more notorious, make more people aware of the work that everyone is doing here. So every one of your stars helps. Thanks a lot. In terms of Slack, as we were saying, we have this contributor Slack. We have also the support channel for any questions that you have. We are way over 5,000 members now, with almost 300 members coming meeting after meeting after meeting, which means that we are around 250, between 250 and 300 new members every month, which is an awesome growth. So if some of you here would like to continue the conversations that we have, would like to ask further questions, we are more than happy to get your feedback, get your questions, make sure that you are successful using open metadata and that we can help you move from POC into production. And Suresh is saying that the stars went down by one. Hopefully, I'm not overselling it. I will shut up now. But I knew I should not have jinxed it. But then going back with the rest of the stats here, if you don't want to miss any other meetings, any other announcements about the new releases and whatnot, you can either check the announcements that we have in Slack or follow us as well in both Meetup and Twitter, where we'll keep sharing all of these things. In terms of community contributions, drilling a bit down, last meeting we had 12 highlights. Today we are with 11 highlights. So thanks to everyone for your fixes, helping us with the docs, with the Docker composes, fixing bugs, creating new connectors. Again, we are super excited to see more and more people getting hands-on with the project. This is all that open source is about, making sure that we can push together to make open metadata even better day after day. So thanks to all of you for your continued support and contributions. And if you would like some swag, we just did a nice shipping of open metadata t-shirts, open metadata caps. I think that we also have notebooks, pens, stickers. We have a lot of things. So if you want to really go and wear some nice fashion, feel free to contribute to the project. Here we sent swag to Kent, Marius and Dominic, to Shiyang, to Sander Van Laar, Megumi, Anatoly, Gotham, and Locke for their help with MS SQL, with creating new connectors, creating translations to different languages. This is a very important one. So if you are missing some translations in Open Metadata, it's super, super easy to add your native languages in there. Otherwise, we try to do the best job using ChatGPT, but if we have some native knowledge, it's super, super helpful to make sure that we are getting the right words. And we also got here, I think that we also highlighted on past meetings, PGP, Spider, Greenplum, Light Dash connectors, and Log was also super, super helpful, giving us some more improvements on Looker. So thanks again to all of you that are here to help. I hope that you enjoyed the swag. If you did, feel free to share some pictures of how you're rocking those t-shirts, how you're enjoying your morning tea of coffee. We would be super happy to see that you're enjoying this swag as well. Then, before we jump into the release topics, let's review, as always, some numbers on how the community is doing. As you can see, PRs continue to be through the roof. The week that was the calmest one because there were some holidays here and there, we were at 40 PRs being merged, but we are in a steady between 40 and more than 60 PRs week after week that the team and the community is putting on. So that's amazing effort. That's a lot of new things that we are cooking for new releases. And in terms of Slack, as we were saying, we have this great support channel where you can go, you can ask your questions, you can give us your feedback. We are more than happy to help. And we are steadily really crossing by a lot the 100 questions per week. And just on the last 4 weeks, we got more than 500 questions. This is really great numbers. The engagement that we're seeing in the community is awesome. We are doing the best that we can to get back to everyone to make sure that all of your topics are unblocked and you can continue to push further the adoption of open metadata in your organization. If some of the questions already ring a bell, don't be shy. It would be great if you give us a hand into answering all these questions and you can chip in, because I'm sure that especially in certain connectors, deployment modes and so on, there's people that has been here release after release after release, that you are really cooking up all of this knowledge. So don't be shy. Help your fellow community member. Help us make sure that everyone is enjoying as much as possible their journey with open metadata. And that being said, let's start with some of the highlights that we're cooking here for the release 1.4.0. So right now, versus the 1.3.0, we are already surpassing the 450 commits of fixes and improvements and new features that are coming in. And this is just a small extraction of all the notorious things that the community is building. On the one hand, for Collate, we have the MetaPilot, which we are just going to show in a few minutes. We are also hooking up these metadata actions, this way for you to create these automations, to propagate lineage and tags via, descriptions and tags via lineage, to bulk add some tags via some expressions or via some specific, like this table contains the user, then I want to add PII tags. So we are really adding all of these bulk actions that you can add on top of your whole platform. We have as well the Click Cloud as a new connector. We are improving the alerting system. We are also improving a lot, and you're going to see, I think that you'll be super impressed of what Pablo and the rest of the team were able to book during this release and that we're going to show you just today. We're also going to add the tables DDL directly into the UI so that you can see all of these different properties and how that table was actually created. We are also adding the Azure Services Identity. which means that, for example, if you want to extract metadata from ADLS, you want to extract metadata from an Azure SQL instance and whatnot, we are going to make the necessary changes for you to directly use the IAM roles, quote unquote, equivalent that Azure is bringing on top of the table. We are going to improve a lot how we can handle the SSL certificates for connectors so that you can directly upload into the UI those certificates instead of having to copy paste the values, which we know that it's a bit cumbersome. So we want to make sure that this experience is as easy and as smooth as possible. In terms of secrets manager, right now we support the AWS Secrets Manager and the parameter store to save the sensitive information from your connectors. And we are rolling out Azure Key Vault as another way that you can hook, that you can properly secure all of your sensitive information for those of you that are deploying open metadata in the Azure world. As we were saying, we are going to add these extra bulk operations so that you can edit more descriptions, add more tags in just one single go. We are adding extra custom property types as well as suggest APIs for us to keep building on top of the backend. And again, those are just some highlights in the 1.4.0 release. We are going to be bringing much more fixes, much more improvements. Be tuned, keep us raising your questions and your requests, and let's make sure that we can keep improving open metadata together. And that being said, let's start with the actual content for today. And for that, we are going to take a look at the MetaPilot. But before we jump onto this, let's make a quick refresher for those of you that are just new to the project or at least to the meetings on what are the foundations of open metadata and how that actually helps us unlock the AI capabilities on this metadata platform, right? And the idea is that everything that we're building is based on mainly two things. It's based on this standard language that we are putting on top of the table. And by a standard language, we mean what it means to be a table, what it means to be a dashboard, which shape we can expect to get out of the server, and also what the server expects us to send there. And this is a very powerful and very important idea because in the same way that here we're able to understand each other because we make the effort of speaking in English, it's also important that we have these very well-based expectations on how we can exchange, in this case, metadata information with the Open Metadata Server. And in order to make this actual exchange, everything that we build is not only based on the language, but also based on the APIs, based on this closed set of rules on how we can send certain information, how can we create some tables, how can we extract them, how can we update all of those pieces of information. And everything that we build is based on these two things. So if you go on the UI, you start clicking around, everything that happens on the connectors, all of that is based on this standard and on these APIs. And that's the foundation, not only of the project, but also of our vision, right? What we want to do is to foster innovation. We want to make sure that we can keep expanding the capabilities of the metadata space in the data industry, which means that let's just stop rebuilding the wheel, right? Let's just stop every time that we have this new idea about, oh, it would be super cool if we could create this automation on top of our metadata or whatnot, instead of having to go and think, okay, how can we define the table? How can I exchange that information and whatnot? What we are doing here is we are putting all of those foundations, we are putting all of those ingredients so that we can keep building applications and automations and more capabilities on top. And this is especially important when we're talking about AI tools, because this helps us get into this very nice cycle where we can extract the metadata from our platform, send this metadata into AI tools, and then let these tools populate back into our metadata platform, right? And based on this idea is how we are building all of this set of features and automations on top of the platform. So as you can see right now, by taking the column data and the sample data and applying NLP models, we're already capable of automatically tag PII data on your assets. If you didn't know that, we actually have this capability right there in the profiler workflow. We also have, if you remember when Teddy was presenting the incident manager, we can take the data quality information, we can take the lineage information and whatnot, and have an automated classifier trained on our data where you can actually then get severity classification for your incidents. And we are keep building on top of that, right? Another thing that we can do is say, okay, let's take the schemas of the databases, get a Gen AI model, and take automated descriptions. That's one of the features that we have on the MetaPilot. Or take SQL queries, get an SQL specialized Gen AI tool, and get us a way that we can fix the queries, rewrite them, get optimizations and whatnot, which is, again, one of the features on the MetaPilot. Or, for example, we can take the trends of the profiling and the data quality, do some time series analysis, and figure out some anomaly detection, which is yet another feature that we are building here. Or how we can get the rest of the metadata of the platform, be it glossaries, be it tags, be it whichever other asset we have, again, apply NLP models, LLM and whatnot, and unlock semantic search on everything that's going there. And all of these things, in the end, we're able to create them. We're able to keep feeding back the platform with all of this knowledge thanks to this standard and these APIs. And that being said, let's just start with our demo on the MetaPilot, where we're going to mainly show three things today. How can we have bulk automated description generation? How can we use natural language with a chat interface to get SQL queries generated for us? And how can we take the help of this copilot to optimize and fix the queries that are already there on the platform? So if I go now here into the tool, I will zoom in a tiny bit just to make it easier for you to take a look. And this is what we are building. As you remember, we prepared all of this applications framework, right? We prepared this approach where we can keep building other automations, other workflows for you to interact in different ways with the metadata that we have into the platform. And one of these ways that we are creating is exactly this one here, the MetaPilot. And if we take a look on the app, you're going to see that it's very similar right now to what we have, for example, with the data insights or with the search reindex. But if we take a look at the configuration, let's try to understand the different pieces that we have here. On one hand, we have these databases for automatic description generation, which means that you can select different databases for your system. In my case, I just selected here for this demo the dev database for our Redshift, but you can take a look of any of the databases that you have. You can select them, and then the MetaPilot will help you creating the descriptions automatically for all your data based on the schemas of these different databases. And you can also select in which database you want to use by default to chat with the MetaPilot. And we're going to demo that in a tiny bit. But let's start with this automatic description generation. So we select the databases that we want. We go on this schedule. We can have this run whenever we want. We can even trigger, we can redeploy it, whatever it is that we need. As you can see, this is the same experience that we have with Insights or with any other automation workflow. And once this runs, let's take a look at my dev database that I have here in Redshift. This is the database that I have connected. And let's take a look, for example, at this dbt shuffle. And as you can see, I was playing around. There are already a lot of descriptions being generated, but I was saving the orders table for our demo today. And this would be one of the first examples that you would get once you just go and start integrating some metadata. If you are lucky enough and you have descriptions in dbt or you have directly the descriptions in Redshift, you might see already some more, let's say, interesting information, right, in this panel. But what would happen if you are a data steward or whatnot, and you really need to hydrate all of these systems for hundreds and hundreds and hundreds of tables? It's okay. You know that we can crowdsource all of this information. We can come and we can edit. We can request other people to help us. How can we can make all of these updates? But right now, we can directly rely on AI tools to actually make our lives even easier. And as you can see, we have here the MetaPilot icon that is saying that we have 10 suggested descriptions. And if I take a look, it's going to tell me, hey, maybe one possible description for the orders table is that it contains certain pieces of information and whatnot. So I can take a look, I can figure out, okay, maybe this is a nice starting point and I can accept it. Then I'm going to go column after column and we can take a look and if we like these descriptions or not. So maybe this one I like, this one I don't like. And as you can see, bit by bit, all of that automatically gets applied to the schema of this table. And the MetaPilot is still here and saying, hey, I'm still have 6 changes. So we can either stop here, maybe we want to come tomorrow, continue reviewing our work, or we can say, hey, the rest, they are actually look good. Let's accept everything that we have there. So this is how we are starting to explore all of this experience of coming here into our different tables, make sure that we can easily get some nice improvements into the metadata that we have. And the same way that we got that on this orders table, I can pick up, for example, the staging customers, and we could redo the same information. In this case, maybe instead of accepting, I can just reject all because I read them. I did not like the results. So we just get all of this information properly cleaned up and we can continue to move on. So that's this first experience, this first feature that we're rolling out with the MetaPilot about helping us making sure that we can create and maintain high quality data products directly here within Collate. Then the other interesting experience here is maybe you notice that in any of the pages that I'm at, there's this nice MetaPilot icon that it's following me, right? And what I can do here is we can click and we can ask questions to this chat that it will help us, let's say, explore our data in a different way. Because we know that we can see here, we can go to explore, I can figure out some of the tables, or I can go into the glossary and I can find out the data from any other way. But right now, what we are also bringing on top of the table is a way for you to directly get queries generated by the MetaPilot to help you figure out what's the right table that you need for your different use cases. So as you can see, we have been testing this quite hard, but I can create a new chat. And as you can see, it's telling me, hey, let's ask a question in the dev database, which is the one that I configured before as a default. If for whatever reason I would like to ask questions in any other database, we can come here, we can change that as well. But for now, I'm going to keep my questions onto the development database. And one thing that I can do is, for example, ask it to please count me the numbers of customers that made a purchase in the last 30 days. And let's see what the MetaPilot can come up with. So this is going to say, hey, not only giving me the query, but actually giving also the explanation of this query. So it's telling me, hey, first, actually, you need to filter the orders table, and then we can go on and we can start counting the different IDs that we have here. Then maybe this is good enough for me, or maybe I just need to keep having this conversation with the MetaPilot, and I can say, hey, instead of just giving me that, let's filter the purchases that have been canceled, right? Because if they are canceled, maybe they are not necessary to me. I don't want to build a dashboard based on that. So we can keep iterating and it's going to say, hey, okay, actually what you can do is first filter by the date, but then let's add this other filter by this status canceled. And if we go again into our database, and we take a look at our orders table. So you can see we have the customer ID, we have the order date, and we have the status. So this is a very nice, comfortable way for us to really have a very fast, quick start when we are doing all of this analysis job before we start building our pipelines of our dashboards. Then what it's very important to see here is that what the MetaPilot expects is for us to ask about queries. So what would happen if I just go completely off the record and I ask the MetaPilot what's the character of Star Wars? Let's see what it's able to come up with. This is not a valid SQL query. So for now, this experience is based on helping you create, helping you fix, help you optimize any query. So those are the main answers that you can expect from the MetaPilot. And bit by bit, we will continue to build on top of that. We will continue to iterate to have even this semantic search and this full chat experience that we were just discussing in the beginning. Another interesting piece that we have here for the MetaPilot, and for that, I'm going to go into the customers table, is let's take a look on what we can use this copilot for the queries that are already registered in the tool, right? Because you know that if we go here into our service, we have a bunch of different ingestions that we can use. We have the DBT ingestion, the metadata ingestion, the profiler, we can add lineage, we can add the usage ingestion. And one of the interesting parts of the usage ingestion is that it's going to scan our databases. It's going to figure out which are the queries that are running against that database, and it's going to populate this query step here. So we can either rely on the usage workflow, or we can come here and manually add a query. And we're also going to do that in just a tiny bit. But what is interesting is that once we are here and there's already some queries, what we can do is say, hey, maybe I need help into actually understanding what is going on here. So maybe we can go and we can say, hey, MetaPilot, can you explain this query? And we'll give the MetaPilot just a few seconds. And it's going to say, hey, we are actually counting the number of customers' IDs where there's no status that was failed. And we can keep iterating again. We can keep asking, figuring out what are other ways that we can expand this query. Or we can have maybe a more typical example on we have basically a query that was either picked up by the system or anyone else in your team, as I'm doing now. I'm copy pasting this query. And as you can see, there are a couple of things that are a bit smelly, right? On one hand, I'm actually missing a parenthesis here on discount, and here I'm not using the single quotes. So it might be actually thinking that, okay, maybe there's a column name failed or whatnot, but this is really something that if we try to run it, we are going to get into issues, right? So let's imagine that we come here, we are actually copying this query, we go to our database and this is failing, right? And we actually have no idea why this is failing. So we can come to the MetaPilot and we can say, hey, can you please fix this query for us? We'll give it again a few seconds and it's going to say, hey, let's start with that and let's filter out, but it was able to actually remove the double quotes for the single quotes and pick up and fix the parentheses here. And I can also come and say, hey, can you optimize this query? Because maybe like we don't really like this predicate with a not in or whatnot. Maybe there are better ways that we can run this query. And again, this is just a simple example, but the harder the query, the more useful that it's going to be. And this is actually going to say, hey, maybe you can use the not exists and take the information out of this other table. So as you can see, this is really handy because it's not only helping us understand the information, it's helping us fix the information, it's helping us find the right pieces of information in the different database with very nice worded error messages in case that we are not getting the right SQL queries and whatnot. And again, this is just our first iteration, our first version for the MetaPilot. We're super excited to be entering this Gen AI world with LLM, retrieval augmented generation. There's a lot of literature that we have going around. It's super exciting. And we are really, really happy that we had all of these foundations, all of these schemas, all of these APIs to bring this to life into such a central product as OpenMetadata and Collate can be in the organization. And with that being said, when we also shared the slides, we had some screenshots here just in case the demo gods weren't with us today, but I'm happy that everything appeared to look good. Otherwise, we have the nice screenshots of everything that you can expect as well out of the MetaPilot. And that being said, I'm going to pass the word to Pablo that it's going to explain us how we are making all of these performance improvements on the ingestion framework. Thank you.
Thanks, Pera. Hello, folks. Let me just share my screen. Give me a moment. So, I'm Pablo, and I'm actually quite happy to run you guys through the improvements that we've been doing for the ingestion framework. And there are basically two of them. First, we're enabling some multiprocessing extraction, and the second one, incremental extraction. But before getting into what they are and how they work, I wanted to do a quick recap on what the ingestion framework actually is. And in a nutshell, basically it's the engine responsible for extracting all the data from the different sources, mapping to the metadata standard that Pere was mentioning before, and then send it to the OpenMetadata API so the server is updated. And you can use it either directly through the UI by configuring the ingestion there, or also programmatically using the Python SDK. So for instance, a common flow here would be the user just creating the ingestion through the UI. It will be saving to the server that will deploy it into the orchestrator. And on a given schedule, it will run to extract all the data from a given source system, then update open metadata with a new info. From the framework itself, I think there are two interesting main ideas that we can focus on for these specific improvements. And the first one is the separation of concerns. So the workflows are built into several steps that they are main, the source, the process, and the sink. And we could think, for instance, on a lineage extraction, that maybe you need to go on the source, get all the query history, then maybe you need to tokenize it, process it somehow to build the actual lineage. And by the end, the sink is responsible for updating the open metadata. Focusing a little bit more on the source, we also have a topology defined for each different service that basically is related to the open metadata standard. So this example is about a database service. We have the database service itself that has one or more databases. Each database might have plenty schemas, and each schema a couple of tables. So then we extract the data in this hierarchical order. Now, with those two main concepts in mind, we can go into the multi-threading extraction that will be at the schema level for databases only on this beta release. And when we think about that without multi-threading, we basically go through the topology, and for each stage, we send the data directly to the sink sequentially, and it is processed. Now, when we feature in the multi-threading implementation, things change a little bit. Since we're doing it at the schema level, before that, each node continues the same, so sending the data to the sink directly. But then at the schema level, we're able to deploy several threads and process a couple of schemas concurrently that would basically send the data to a queue. And in the main thread, that queue will be yielding back the data to the sink. And the important bit here is that basically it's the topology that allows us to process several schemas concurrently, but also keeping within each schema the hierarchical order that we actually need it to be. While developing this feature, we did a lot of performance tests, and it's quite interesting that it improves a lot the performance, especially on at least our BigQuery instance. But it will be good to notice the scenario that we're testing in, because since we're using the multi-threading at the schema level, this is probably better for the use case where you have a couple of schemas with a lot of tables, so you can make use of those different threads. Now, there are a couple of general considerations that I think it's good to think about. And it's mainly that each case is specific. So more threads doesn't really mean you'll have a better performance. And you need to take into account that each thread basically increases the load on the database, because we open one connection per thread, you'll have more connections at the same time. And it will also increase the memory footprint by the ingestion framework, because we need to hold more context in memory to be able to process everything at the same time. Because of this, we basically recommend testing different approaches and starting lightly on the threads. So maybe 2, 4, 6, and see how it fits better for your use case. And worst case scenario, if you are unsure, it's not improving, or you're having any issues, besides letting us know, because we can always improve on it, it would be good to leave it at 1. That will basically fall back to no multi-threading at all. Now, how does this look from the user perspective? Depends a little bit. If you are configuring your pipeline from the UI, you'll notice a new attribute towards the bottom, number of threads with the default value of 1. So no default behavior will change, but you can change into whatever you see fit. And if you are actually using the YAML file approach with an external extraction, within the source config, there's now a new attribute called threads, where you can input the value that you wish. That's basically for the multi-thread. And the second improvement was the incremental extraction. So while the idea of multi-thread is to process more stuff at the same time, the idea of the incremental one is to actually process less things. Why is that? Basically, we can think about two different patterns of getting data. The first one is the pull pattern, where we basically need to go to the source, get all the data. And the issue is that normally we don't know what changed, what didn't, what exactly which data we need before you actually get it. And the second one is the push one, where we basically receive the data and something external is actually sending it to us and it's responsible for the data that we receive. Normally we can receive it in a more timely manner and just exactly the data that we need. The issue is that, well, databases don't really send us events so that we can implement this, at least not out of the box. And in order to kind of improve a little bit on that, we thought about the following approach. What if we, instead of getting all the data always, we look for a previous successful pipeline run, get the time when it started to run, maybe add some safety margin just to guarantee we're getting all the changes, and update only the assets that actually changed. So with this extra initial step, we could basically avoid processing a huge amount of data, no? And that's what we did. So thinking about the flow, without incremental extraction, it's the same as you saw on no multi-thread, just the regular teach stage. We push stuff to the sink and we process everything. Now with the incremental one, there is an extra initial step that will fetch the last successful pipeline run from OpenMetadata. Maybe it was yesterday at 2 a.m. Then you could add the safety margin, let's say 1 day. So it will try to get the changes of 2 days before until now in this specific case. And with those changes, it creates a map that will be used in the source. So again, because of how the topology works, we can just keep everything normal until we arrive at the get table node that will use the changed map to understand what it actually needs to process and what not. So how does it work? Sadly, there's no standard way of doing it for all the databases, and that's why we started with these three. On the BigQuery scenario, we are basically querying the cloud login to get the table changes because BigQuery sends a lot of login events to specifically the login tool. For Redshift, we need to query the sysquery history table, get the query text and actually parse it to understand which tables were created, deleted, updated. And on Snowflake, we actually have the account usage tables that gives us exactly the last time a given table had a DDL change. Like with the multi-threading extraction, we perform a couple performance tests with interesting results. In this case, we basically wanted to understand what was the control. So how much we were taking with not an incremental extraction. Then what will happen if we actually configure the incremental one and all the data changed? And what will happen if only 90% of the data changed, 50, 25, 10, and a couple of other percentages? And it's quite interesting, actually, more visible here in Redshift than Snowflake, that if you configure the incremental extraction, but most of your data change all the time, or either because it changed or maybe you configure a really big safety window, it actually gets a worse performance. And basically, why is that? In the end, this initial step is an extra overhead that it's not, and the amount of data that you process, since it's almost everything, it's not good enough to balance it out. So the big take is we need to configure it well, so we only get the latest changes that we actually need instead of a lot of duplicated data for that. Now, from the user's perspective, basically we have three configurations. The first one is a toggle, so you can just enable or disable it from the UI, also while configuring the ingestion pipeline. You can also play around with the amount of days you look on OpenMetadata for a successful pipeline run. And last, the amount of days that you want to add as a safety margin to guarantee that you are picking up all the changes. If you use a YAML file for the ingestion, similar to with multi-threading, you'll have in source config, and new attribute called incremental with the three configurations that you might tweak. But there is one extra step here that you also need to add ingestion pipeline FQN. That is basically the service name dot the pipeline name that you want to give. Because from an external ingestion, basically the process is not able to understand which pipeline they should look for. So it needs that extra hint. And last but not least, if for some reason you think your process is slow, or maybe you're just curious, we also have a small addition to the debug log, and it's the execution time aggregate that you might see by the end of the process as this summary. We end up logging a couple of different things, but the main things that you should actually look at are actually the sync row and the source row, because then you will have an idea of how much time the process is spending actually updating the data in OpenMetadata or fetching it from the source. Cool. Thanks, guys. It was a pleasure. Yeah.
Hey, thanks, Pablo. Just to give a context about why we have went through this path, right? So there is several things here. There are misconception about, hey, how do we do streaming of metadata, right? There is nothing of streaming of metadata that exists in the world today. The reason for that is data warehouses, databases are not good at generating the events on metadata changes. They do not do that. Like Snowflake doesn't do that, except for example, probably in Hive, none of your data warehouses generates an event when someone creates a table, someone changes a table, whatnot. So then what happens? How do you go about actually getting the metadata, latest metadata? The only option that there is to fully scan the warehouse and look for all the information schema updates and do the updates on the OpenMetadata side, right? So that's what we are doing. That's the best case scenario. That is what available today. So now the question is, there are a lot of use cases that comes around. Hey, how do I get the metadata as soon as it changes? I want to kind of scan periodically much faster. And in case of Snowflakes and other those kind of data warehouses concepts, the longer a session runs, the more money you are paying for Snowflake, right? So how do you reduce the cost about extracting the metadata out of these databases? So that's where this entire work focuses on. And this is like a really hard work in terms of figuring out for each databases how to actually turn them upside down, to look into that, access logs, wherever we can, history logs, to figure out where the database is changing and making that as an event. And now you can run these ingestion pipelines much more often, much faster. Your metadata gets reflected in OpenMeta much faster, much cheaper. So all of these are benefits coming through the collate. So that's a big, huge change. And I'll congrats to Pablo on getting this done. This is an amazing work, and by far the only system in the metadata world that we are doing right now in open source or in proprietary to get the metadata much faster. So these are the improvements we continue to upload and push in into OpenMetadata. So thanks, Pablo.
Thanks, Pablo, for the presentation. I always get the chills when I see those graphs with the big percentages. Let's save people some money. I think that BigQuery and Snowflake are already expensive enough as they are, so let's make sure that we are not adding on top of that. And we still have a few minutes, so I think that we can open the floor for any questions. So if you are shy, you can type it on the chat, but I think that it's funnier if you just unmute yourself and ask live. We are all here. We are happy to answer. So let's see if we can get a conversation going. There's one in the chat. Okay, I missed that. Just to confirm, the MetaPilot suggests description of the table and columns based on the column name and table name, right? Is it part of a paid feature or is it part of open source? Okay, so correct. The MetaPilot description is based on the schema of the table, and this is part of our collate offering. And I think that we also presented that on our last meeting. We are joining forces with why they are experts also on the query generation and whatnot. So if you'd like to see the MetaPilot in action for your organization, do give us a ping and we can get in touch. The MetaPilot bot, does it give the queries in the SQL flavor of the databases? I think that right now we are using ANSI SQL. And this is part of the improvements just to make sure that we are getting the right types for all of the different connectors that we actually have covered here in OpenMetadata. I think that talking about the MetaPilot, these kinds of questions, I think that there were also people asking, hey, can we also ask in the MetaPilot in different languages, or can we get the description in the language that we have OpenMetadata and whatnot? So all of these kinds of, let's say, quality of life improvements to make sure that we can continuously make your life easier are also part of the roadmap here. Oh, this is for Pablo. How did you compute if the data changed or not? Do you take the checksum? Maybe I missed.
So it depends a little bit on each system, but basically BigQuery has the cloud, actually GCP has the cloud login application where BigQuery sends the logs of many things that happen. One of those is basically any DDL change or create, alter, drop, comment. On Redshift, we have this system table where they also have basically all the queries that run. A couple of them as well are the DDL ones like create, alter, drop, comment. And in Snowflake, they actually have this nice table that tells us exactly which is the last DDL date where it happens. So it's pretty straightforward to query and get table names.
Yes, so here Suraj is saying that DML is used for figuring out what's changed. And yeah, we are basically filtering out the DML operations from these system tables, right? So that instead of going back and scanning out all of the metadata, we can just figure out, okay, looks like there were a couple dozen tables with a DML. Let's recompute the metadata from there and then let the server figure out the changes. And Tiago is also asking, will column lineage between entities other than tables be released in 1.4 release? Thank you for the great work. Thanks, Tiago, for asking, and thanks for the message. And yes, so on the release 132, we are actually already expanding the backend and the UI so that we can have column level lineage. Let's call about lineage details between other entities, right? So that we can have data models and tables or between Kafka topics or these kinds of things. And we are actually already starting to do the work on these certain connectors like Bit, Power BI, Tableau, and whatnot, so that we can link the table columns with the data models columns as well, so that we can bit by bit keep adding all of these details. Okay, now we have Vidul Chada that is saying, is semantic classification of data currently supported? Example, column named address may contain phone numbers or other data and not actual address data. No.
We do so through PI processing, tag processing models. So the classification of the data is already happening through the profiler. We do look at not just the table names, column names, but also underlying data. For example, you may have column name as address, but there might be some garbage in the column name, so we won't tag that as an address. But you may have column name as XYZ, but it has addresses. So we have all that intelligence baked in. So as part of the profiler, you can try that out.
As long as you enable the sample data.
So one of the things about our GenAI integration is it's not just about table name and column names. It's looking at the entire schema, right? Starting from database, schema, and tables. So all this schema and, the names, the description there, including, underlying sampling data, all of those things will be considered as we move forward. And, it's not just names, right? It's beyond that.
Is incremental ingestion available for SQL Server database or databases other than BigQuery, Snowflake, and Redshift?
No, the initial release is basically for BigQuery, Snowflake, and Redshift. But if you need for any specific flavor, I think you can ask a feature request in Slack or open an issue on GitHub, and we'll take it into account.
Yeah, exactly. So the big chunk of work that actually went here is two flavors, right? First, make sure that the ingestion framework as a framework can properly support these kinds of ingestions, which we now have checked. And the other interesting part of work was actually validating that doing the incremental ingestion with our framework was actually giving us the expected results, which luckily it is. Those are the figures that Pablo was showing. So now that the framework is there, that the idea is properly validated, adding any other flavor, as long as we have the capabilities of getting on these system query logs and try to understand and filter out all of these DML operations that also Suresh was mentioning before, we should be able to add that. If any of you here also have some interesting SQL Server knowledge, because in my opinion, that's a very hard database. So if you know maybe at which tables we can take a look that they are already getting the right information, or you would like to contribute that, Pablo will be more than happy to help. Sharp on time. Thanks a lot for the attention. Thanks a lot for being here. Thanks a lot for being with us. Another community meeting. Hope that you are all as excited as we are, and really looking forward to see you not in 1 month. Hopefully we'll see you before on Slack, getting your questions, getting your feedback, but at least the latest. See you on the next community meeting. Thank you very much. Have a great rest of your day.